Hello everybody, welcome to my N-scale Willow Creek subdivision layout. Here, my name is Scott. I am the owner and builder of this layout, and I'm going to do a video here on how I power my turnouts. How I get reliable running through my turnouts. Being a switching layout, that was one of the big priorities, was to get positive power through my turnouts to stop the locomotive stalling. The layout that I run, obviously N-scale, it runs on Pico code 80 track. All of the turnouts are Pico. I run obviously electrofrog turnouts. I have 3 turnouts on the layout that are initial frog, but they're more in the locomotive depot areas where there's not so much switching going on. But the turnouts I use, I've got a few of the large radius turnouts, but mainly I've stuck to around about the medium size turnouts there. I run Pico SLE 396, which are left hand medium turnouts, and the Pico SLE 395, which is the right hand turnout that I use, and keep them all sort of uniform. I didn't want to switch it up with other brands, so everything is a Pico electrofrog bar those 3 initial frogs I mentioned earlier. I was meaning to get a video out on this out a little bit earlier, and I've gotten around to filming one now. I've got a little bit of spare time, so I just wanted to show you how I wire up my turnouts for trouble-free running. And I mean, this isn't exactly breaking news, brainwave scientific discovery, but it's just how I do it the cheaper way. I run DC, so I'm not running I don't run any tortoise switch machines or anything like that through my throttle. Everything's done with push-pull rods, as seen in a couple of my previous videos, but basically show you how I achieve it with cheap ways of doing it. I mean, I'm not going to spend, I know turnout motors and that switch the polarity for you when you switch them, but I got like 56 turnouts on this layout, and I'm not going to go and splurge out on 56 point motors. So basically trying to do it on the cheap, and it works really well, actually, a little bit too well. I actually surprised myself. I'm not exactly an electrician, but I managed to wire these up to so I haven't had any dramas at all with these. But yeah, stay tuned for the video, and I will show you how what the micro switch looks like installed. Basically, it's just a switch that has an actuator arm on it, and when the push-pull rod is pushed in, it changes the polarity of the frog, and when the rod is pulled out, it'll change the polarity of the frog back again, so I've got continuous power through the frog and not relying on the switchblades. So yeah, stay tuned and we'll get into the video, and hopefully you might learn something from this, or this is probably all something you might even know, but I'll just share it with you anyway. Alright, here we are. We've got our turnouts obviously here. This is what it looks like from above. Now, how I put in my push-pull rods, they come in, and I have the hole on the opposite side of where you're viewing from, so it's basically not seen. You can't really tell, but there's a little brass wire that comes through the throw bar there, which actually switches the turnout, and it's all done, obviously, as I said, by push-pull rods. So throughout the operation of my layout, there's actually only reason you need to reach across the layout is when you're coupling and uncoupling cars. Everything else is done from the fascia. Even the loading and unloading of my live gravel trains is all done from the fascia, apart from uncoupling. I wanted to make it as automated as I can. But basically, with the throwing of the turnout, as I'm doing that now, I'm changing the polarity of the frog here. When you do this, obviously it's an absolute must. You have to have insulated rail joiners on these two rails here. These outside rails are fine. They got steel or metal rail joiners on those, but you need to have insulated rail joiners on here because you're changing the polarity of this frog, and if they're metal, you're going to run a short. So with insulated joiners on there, this frog will change polarity. Now I've actually got my wires soldered onto the back here, always on the back side from where you're viewing from. I solder the frog wire directly behind there, and sort of keep everything hidden from view. You wouldn't even know there was a wire soldered onto the back side of that. And it's basically trouble-free running. I don't have any issues with my push-pull rods or anything. But that's what it looks like from the top. And I'll just warn you now, just be prepared. I'm about to take you under the layout and I'll show you what the underneath of these turnouts look like and what the micro switches look like when they're wired up. Alright, so I did warn you. I'm trying to do this with one hand, sort of crouched underneath the layout here, but this is the micro switch I'm talking about. And these are actually, they're well overrated for this job. They're 250 volts rated at 5 amps, so definitely over engineered, but they work extremely well. The green wire here, it sort of looks blue in the video. Sorry for the light, there's not much light under here, but this green wire soldered onto the tab over here, this runs up and up to the frog underneath there. And my yellow and my black wires, they run out down to my bus wires. All the layout, the layout's DC and it runs off a DC bus, and everything is connected onto the DC bus. So as I go to pull the turnout, I'll pull the turnout back and you'll see the arm move. And as the push-pull rod goes in, it pushes the actuator arm in and it clicks it over, which changes the polarity for me. And these push-pull rods are basically N-scale rail with an L-shape bend on the end of them. And the hole in the baseboard, I don't know if you can see, but there's a small brass wire that goes up to the throw bar. So as I'm turning as the turnout is switched, the polarity is changed by the movement on that actuator arm there on the micro switch. The push-pull rods made out of N-scale rail, offcuts of rail, are held on by these electrical clips. These are cable clips that are just screwed up underneath the baseboard. Because this is flex track rail, when the turnout is thrown across onto the far side, and for some reason you may knock the control knob on the fascia, it'll actually bend the rail rather than damaging the throw bar on the turnout or anything like that. So there's enough strength in it to push that bar across, but there's not enough strength in it to damage the throw bar should it get pushed beyond its limits. Alright, here's a wiring diagram that I have of the how I've wired up these micro switches here. And what I've got here is basically, obviously the micro switch there, where I've labelled the micro switch in the middle. There's 3 wires that run this whole system. I run a DC layout, so I've got a DC bus under my layout. So the feed wires come directly from that bus to the micro switch, and the little tab at the top of the micro switch is where the frog wire comes off and it's attached directly to the frog. Over here is a drawing of my push-pull rods here. Now the end of the push-pull rod that actually sticks up through the layout to the turnout, it's a little tiny bit of brass wire that I use that fits snugly into the throw bar of the turnout, and that's how the turnout's actually thrown. It's soldered onto that because I use N-scale rail. It's easy to solder these pieces on. If for some reason there's terminal strips, other wiring in the way, I will solder down the rod further another piece of rail on there that will act as a bit of a something that activates the micro switch lever that runs out here. This is the lever you saw in the video before. As the rod goes in, it flicks that up and flicks it down, changing the polarity of the frog here. Obviously it comes down. This is the push-pull rod end and my fascia. That's basically the wiring diagram as it is. Now, as I said, I'm not an electrician, and I'm not telling you to wire it up like this. I'm not telling you this is how it should be done, and I'm definitely not telling you that you can go ahead and do this. I don't want to be responsible for anyone damaging any locomotives or short-circuiting anything. For the simple reason is when you do wire these up for the first time, the turnout to be in the straight through position, you have to have your feeder wires on correctly. If for some reason your turnout's in the straight through position and you're running a short, that means these wires are around the wrong way. Only when the turnout is thrown, then the polarity will be correct. Only when the polarity is correct when the turnout is in its straight through and not diverging route. But that's basically it. I mean, I'm not an electrician. I'm not exactly a good drawer by the looks of that, but I hope that gives you some idea on how I've wired it up. And it's not a new scientific discovery. I mean, you guys probably already know this, but just for the people that don't, sort of, they're having issues running, locos stalling on turnouts and stuff. This is the issues that I went through, and this is what I did. And I've had any issues so far to date. But yeah, I mean, for those that are running DCC, I'm not sure. Well, I don't run DCC, so I'm not too sure. I can't vouch for them. But for DC running, this definitely works. Okay, here we go. We're back up on top of the layout here, and I'm just going to give you a little bit of a demonstration here. I've got a little GP, what is it, a little GP9, number 226. Now I'm just going to run it up the yard ladder here at Willow Creek. Just show you that I can run up these ladders and without even the flicker of a headlight, and you can achieve nice smooth running with these turnouts. All these turnouts are all wired up for the with all the micro switches. So this locomotive will just crawl through these turnouts here, and yeah, I don't even get a flicker of a headlight or anything as it runs through. There's no, obviously it's DC, so there's no stay alives or anything fitted into the locomotive, but it's that's basically the outcome of my wiring there, and I was actually quite surprised and quite pleased how that turned out. But anyway, thank you very much everyone for watching this video. If you like what you saw there, please hit the like and subscribe to get notified when I do post new videos. I enjoy making these videos, and sometimes I might be stating the obvious, but hey, there's probably a lot of people out there that are new to the hobby, and they're just getting into it and they don't know these sorts of things. So yeah, definitely like and subscribe, and thank you very, very much for taking the time and watching my videos. I do try and make them as informative as I can. And thank you very much, and I'll see you on the next one.